Okay, let's just get right into it. Have you ever actually stopped and thought about, well, the kind of absurd reality of our daily digital lives? I mean, really think about it. How exactly do we manage to force a beautifully messy, continuously flowing biological human mind to communicate with a freezing cold rock? It literally sounds like a joke, but it is the very foundation of the digital age. Welcome to today's Explainer, where we're going to trace this breathtaking descent from abstract human imagination all the way down to physical, microscopic electricity.
So this is the overarching mystery we're unpacking today. We are crossing a massive physical and philosophical divide. On one side of the chasm, you've got your mind. It's warm, it's intuitive, it's fueled by a lifetime of crazy experiences. But on the exact opposite side, you've got the raw, unforgiving silicon of a computer processor, a thing that only understands electrical voltages. We're going to map out this journey to the bare metal to see how a fleeting thought actually becomes a real-world digital action.
Here's how we're going to break this down today. First, biology versus rigid physics. Then, OS alpha and the wet code. From there, we hit the ALU and dry silicon, dive into the modality gap, and finally figure out how to cross the semiotic bridge.
All right, part one, biology versus rigid physics.
To really wrap our heads around this challenge, we first need to look at the foundational divide between the scientific disciplines themselves. The philosopher of science Massimo Pigliucci makes a brilliant point here. He points out that scientists have long suffered from treating all fields as if they should behave exactly like physics, and he highlights a fundamental truth. Think about it. In physics, if you crash particles together in an accelerator, it frankly doesn't matter where those particles came from or what their history is. They just obey absolute rigid laws. But biology? Biology is wildly different. It's massively dependent on history. Living organisms are the result of countless historical accidents, evolutionary shifts, and stochastic, basically random, events. Biology is profoundly, beautifully messy.
The stark contrast here is pretty wild when you think about it. It perfectly sets up the two alien worlds we're dealing with. Biology relies on empirical approximations. There are very few absolute laws because a biological system's behavior is fundamentally tied to its past. Physics, on the other hand, is completely ahistorical. It literally does not care about the past. It operates on rigid, absolute, and repeatable laws. This exact opposition, right here, is the ultimate backdrop for everything we do in computing.
Which brings us to part two, OS alpha, what we call the wet code.
Let's take Pigliucci's concept of biology, this historical, stochastic, messy reality, and map it directly onto our daily experience of human cognition. Because you and I, we're the ultimate biological systems, right? Researchers actually playfully refer to the human mind as OS alpha. This is our fundamental operating system. It's a warm, highly associative, and entirely continuous environment. Just think about it. When you hear a layered joke, or you sense tension the second you walk into a room, you're instantly processing oceans of context. This is what we call wet code. It's probabilistic, it's forgiving, and it naturally bends to accommodate grace and intuition. It is a flowing river of abstract meaning.
Now, let's look at the exact opposite in part 3, the ALU and dry silicon.
So as we've established, we need this flowing river to somehow communicate with a rock. So we have to plunge downward, way past the pretty graphical user interfaces and the smooth software, straight down to the bare metal of the machine. The absolutely crucial point is right here, the arithmetic logic unit, or the ALU. We call this the ALU surveyor because it acts like a surveyor out in the field with a precision laser. It represents the rigid, uncompromising laws of physics. It is strictly deterministic. In the ALU, 1 + 1 equals exactly 2, every single time, on every single machine on Earth. It is driven purely by a relentless metronome of clocked voltage, and it possesses absolutely zero understanding of what those numbers actually mean.
To ground this dry code in physical reality, just picture the literal wires inside your machine. Down there in those physical pathways, there are no semantic symbols. Honestly, there aren't even really ones and zeros in the way we picture them in our heads. It is simply continuous electrical currents being strictly routed through physical logic gates. High voltage, low voltage. That is it. There are no hidden meanings, there are no nuances, and there are definitely no jokes down there in the silicon.
And that sets up part 4, the modality gap, a total collision of worlds.
This brings us to the central conflict of our digital age. It's the massive collision between fluid biological thought and rigid physical execution. We call this terrifying chasm the modality gap. Imagine trying to force a wild, roaring river perfectly through a tiny, rigid, square mechanical grid without spilling a single drop. That is the exact physical friction we encounter here. Our fuzzy, context-aware OS alpha is completely, totally alien to the machine's strict, ahistorical execution.
It's just a massive mismatch of realities. I really want to make sure this sinks in, because it is so incredibly easy to forget when our machines feel so smart. The hardware is utterly blind to human meaning. It doesn't trust you, it doesn't try to guess your mood, and it demands absolute, flawless perfection. If you make a mistake, it doesn't pause and try to figure out what you meant, it just registers physical resistance, throws an error, and stops completely.
Summarizing this whole crisis, we're looking at two completely opposed paradigms. On one side are wet code, meaning-driven, associative, and probabilistic. On the other side, the machine's dry code, voltage-driven, exact, and deterministic. If human language is wet code, inherently ambiguous and relational, then the machine's dry code is mathematically unforgiving. How on earth do we marry these two without causing a catastrophic system crash?
Which takes us to our final step, Part 5, crossing the semiotic bridge.
Thankfully, human ingenuity provided an answer to safely compile biology into physics. We crossed this gap using what is called the semiotic bridge. And the answer? It's text. Specifically, strictly formatted text and code, like a Python script or a JSON file. This structured text acts as the universal deterministic interface, a kind of divine script, if you will. Text is quite simply the only safe, lossless way we have to compile our associative human imagination directly into the exact physical electrical behavior of a silicon processor. Let's actually walk through how this builds, step by step. Step 1. Your creative intent starts in your warm, messy, biological mind. Step 2. You formalize that fuzzy intent by writing it out into explicit, structured text, that divine script. Step 3. The machine reads that rigid text and executes it perfectly as physical voltages in the ALU. We are physically squeezing fluid imagination into an unyielding bridge just to command the machine's hand. Which leads us to this absolutely brilliant metaphor from our source material. When you really step back and look at the raw physics of what we are doing, we are quite literally tricking rocks into thinking using lightning and text. I mean, how cool is that? There's no magic ghost in the machine. It is just explicit language commanding electrical currents on physical silicon substrates. Our biology is successfully commanding physics through the sheer power of text.
But as we wrap up this explainer, I really want to leave you with a provocative thought here. Today, we are increasingly relying on probabilistic AI to write our code and make our decisions, basically stepping away from writing that exact deterministic text ourselves. So if we abandon the semiotic bridge, if we stop actively acting as the sovereign authors of the text, who or what exactly controls the physics? It's definitely something to deeply ponder as you navigate your digital life. Thanks so much for joining me today. Keep questioning the structures beneath the screen, and I'll catch you next time.